In this video, we will learn Heapsort algorithm. And before that, the viewer must be aware about the max heap algorithm, because this heap sort algorithm is based on max heap. So as usual, first we take an array. So I take an array of size 7. Here I show an array of size 1, 1, 2, sorry, 2, 3, 4, 5, 6, 7. Okay. Now I take the elements. Elements are, first is 12. Thereafter I take 5. You can take any 7 numbers. 3, 13, 13, 7, 9, and the last element is suppose 8. So as I said, that to understand the heap sort, which I will show you the algorithm in this video, is based on the max heap. So I am here making a max heap of the array that you see on the screen. I once again repeat that the heap I show you is not the normal heap of the array, the given array. It is a max heap of the given array. And I again repeat the same thing, that how can one make a max heap? This has been explained in the past videos. Not only the algorithm, but also I have explained the code, the program of the max heap. So one can make a max heap using either the program or by the algorithm. And the first element in the max heap obviously will be the largest element, that is 13, and here will be 12, here will be 9, here will be 5, here will be 7, Here will be 3 and the last element will be 8. 8 is here. This is the max heap of the given array. Now we go to understand the heap sort algorithm. I have not here typed the title, so I type here. I type here heap sort. Heap sort. This is an important technique of sorting. Now I start the heap sort algorithm. In this algorithm, the largest element is removed, and you see the largest element is at the top. The root node is the largest, so I remove that. I remove that. Okay, I remove. See, I remove 13. So at the root node there is no number, so there is no meaning to keep the circle, because I have removed that value 13. So since the 13 was the last element, sorry, the largest element, so I I keep that largest element here at a place. Now if you observe the remaining structure, if you see this, then this structure is not a heap now, because in a heap there must be a root node, but here you see there is no root node. So to maintain the heap, this place, you see, this place is vacant. This place, this circle must be filled, and this circle is filled by the last element, and you see the last element is this one, 8. So the last element will take the place of the root node. So I keep 8 here. Now since 8 has taken place, 8 has been placed at the root node, so the 8 at the end should be removed. This will be removed. Now after placing the last element at the root node, we heapify. Remember, we max heapify this root node. This root node must be max heapified. I have already uploaded a video on this function max heapify, and if you have not seen, then even then it is very easy to understand what is the function max heapify. I show you. So max heapify starts from a node, and that node here is the root node 8, and if you compare this 8 with its children are 12 and 9. So among these two children, 12 and 9, 12 is greater, both are greater. 12 is greater than 8, 9 is also greater than 8, but the largest one is 12. So this 12 and 8 will be interchanged. So I interchange 12 will come. This is the first step of max hippify function. 12 will come here, 8 will go down. Now the max hippify of the root node is not complete. Here you see an interchange has taken place. Whenever interchange takes place, then we go down, and there are two sides of the root node, left and right. You see the interchange has taken place in this part, the left part. So we have to move down the left. So when you come to the left, then you see a small heap, which I am enclosing in a green color. You see the green color. Now you have to do the same thing. This means this time you have to concentrate yourself on this node 8, and you should see its children, that is 5 and 7. Among these three, the largest is 8, and which is at its right place. So there is no work to be done inside this green enclosure. So I remove this green enclosure now, because there is no work to be done inside this green enclosure. Here I removed. So we say that our root node 12 has been max hippified. So when the working of max hippified is complete, then we do the same. That is, now in the remaining heap, the largest element is 12. So I remove this 12. Since I removed the value, so there is no need to keep a circle here. And now since I have removed 12, so 12 will be written just before 13. I have written 12. Now if you see the remaining structure inside the blue enclosure, then this is not a heap, because there is no root node here. So we do the same as we have done in the past. What did we do in the past? We kept the last element at the root node. This time the last element is 3, this 3. So this 3 will come here. This 3 will take the place of the root node, and this 3 must be removed. So I remove, because that 3 has taken place the place of the root node. So to remove that, I use eraser. So that 3, this 3 has been removed now, because that 3 has taken the place of the root node. And we repeat the same process. Now again we max hippify this root. So for that we see the children of 3. We observe to max hippify root node 3, we take the node 3, the root node 3 with its children. You see, you have to concentrate yourself on this green, inside this green enclosure. If you see, then you may observe that among these 3, 9 is the largest number, the largest integer. So 9 and 3 will be interchanged. So I interchange. Here 9 will come here and 3 will go down. Now the next step is, you see, an interchange has taken place. So you must observe that the interchange has taken place in the right part of the root node, this part. So we have to come down. If you go down, then you will see that 3 there has no children. So there is no work to be done. So our working of max heapify the root node is complete. So I now remove the enclosures because there is no need to keep the enclosures. Our work is complete. Now you see that this structure is the max heap, and you know, in the max heap the largest value exists at the root node, and you see at the root node this time 9. So this 9 will be deleted. Since you have deleted 9, there is no need of keeping a circle there. So I removed the circle as well, and that 9 will be taken here just before 12, the last element. But if you observe the remaining structure is not a heap. So to maintain a heap, we have to keep a value here. We must keep a value here, and you know, as usual, the value to be kept here will be the last element, and you see the last element this time is 7. So 7 will come here. Since you have placed the 7 at the root node, then the 7 appearing in the last must be deleted. This should be deleted because here there was 7, and that 7 is now at the root node. Now again we repeat the same thing, that is, the root node must be heapified. The root node must be max heapified, and for that we take the root node with its children, and you see the root node 7 with its children are inside the green enclosure, and in that the root node is 7, which is smaller than 8. So obviously there will be an interchange, and that interchange will go in this direction. I show you the direction. This is the direction of interchange. So 8 and 7 will be interchanged. I interchange both the values. 8 will go up, 7 will come down. Here will be 8 now, and here will be 7. Now you see the interchange is in the left part. So we have to come down, and this time if you come down, then you will have node 7 with its children. There is only one children, no matter. A comparison may be done because, you know, for the comparison we need at least 2. So in the pink enclosure you see 7, the node with its children 5, but in this pink inside this pink enclosure, the largest value is at the node is 7, its child is 5, so node the parent is the largest. If you observe the pink inside the pink enclosure, then 7 is upside, so there is no need to work, there is no more work. So the root node has been max hippified. So I remove both the enclosures now. There is no need to keep the enclosures now. These were drawn only to make you understand. So you see, this heap is a max heap. Whenever you see a max heap, the largest value will be the top node, that is root node, and this 8 will be removed from here. Since you removed the value, there is no need to keep a circle there, because whenever you draw a circle, then you have to keep a value inside that. Since you have removed 8, so there will be no circle, and that 8 will come, you see, gradually that 8 will come here in front of 9, and you observe that these numbers are sorted. This is the process, and we do the next process. The next process will be the same. The if you observe the remaining structure, it is not a heap. To maintain a heap, you have to draw a circle here, and you have to keep a value inside that, and as usual the value will be the last value will be placed at the node. So this time this 5 will go at the root node. So I place 5 here. Since I have placed 5 at the root node, so the same element will not be taken inside this structure two times. So this 5 will be deleted. So the last 5 you see will be must be removed, because that has gone to the root node. And now again we heapify the root node. So for that you have to observe, you have to concentrate yourself on the root node with its children. And if you observe, then you should observe that the largest value is not at the root node, so there will be an interchange, and that interchange will be in this direction. In this direction, and this 7 5 will be interchanged. 7 will go to the root node, and 5 will come down. Here will be, sorry, here will be 7, and here will be 5. Since there is an interchange, so you have to come down in the direction of interchange, and you see the interchange has been taken place in the left side. So if you come down to the left side, then you will have 5, and as there is no children of 5, so there is no work, there is no more work to be done. So there is no need to keep this enclosure, so I remove that enclosure. So this is a max heap, and we do the same, that is the largest value 7 is at the top. We remove this largest value. So since I have removed this largest value, there is no need to keep the circle. So I have just removed 7, and that 7 as usual will come here. Now the remaining structure, if you see the remaining structure, then this is not a heap. So to maintain a heap, I draw a circle here. Since I have drawn a circle, this circle must contain a value, and as usual the last element will go inside this circle, and you see the last element is 3. Since you have placed this 3 at the top, so this 3 must be removed, and to remove that I take the eraser. Okay, this time you see you have a heap, and at the root you see 3 and its children. Its only one children is 5, and you see that the value at the root is a smaller. So obviously, as usual, there will be an interchange in this direction. So 3 and 5 will be interchanged. Here will be 5 and here will be 3. And you see this is a max heap because the largest value is at the top. So I remove this 5 because this is a max heap. When we have a max heap, then we go for the heap sort, and heap sort is based on the max heap, and to perform the heap sort we remove the largest value. So I will remove this time this 5 because this is the root node. So I remove 5, and this 5 will come here. Since I have removed 5, that 5 will come here, and now you see only one value. You see the only one value, and you see that this structure is not a heap. So to make a heap, we have to keep a circle here. Since I have drawn a circle, so there must be a value there, and as usual the last value will be kept here, and that value will be 3. Since I have placed 3 at the top, so there is no need to keep 3 here. So I remove the lower 3. You see I have removed. Now only one element remains, so there is no comparison, there is no interchange, there is no comparison, so there will be no interchange, no comparison. So, and you also know that any array containing only one element is already sorted. So this 3 will come in front of 5. So I have removed 3 this time, so this 3 will come here. Now observe this. If you observe, then these numbers are sorted. You see these numbers are sorted, and this is the algorithm of the heap sort. And you must observe that in this heap sort both functions were used, maxipify as well as the build maxip. So if you don't understand this is very easy. One can easily understand this heap sort here in this video. If you don't understand, then you should see the algorithm of maxipify and the algorithm of maxheap. Okay, thanks.